Math it up.
Where you are, thank you. 4-3. Okay, our first different probability distribution we're going to talk about is the geometric probability distribution. So, geometric. Who's there? Probability. Yeah, it is. Distribution. Okay. This one is different than binomial. With binomial, you knew exactly how many trials you were going to do. I'm going to go talk to 8 people. I'm going to take this 10-question test. You knew exactly how many trials. Geometric, you repeat a trial until you succeed. So you don't know how many trials it's going to take. So that's how you're going to be able to pick out the difference. It's going to be in the question. So we repeat.
It's like the geometric series and the something series. Arithmetic.
Yeah. Trials until you succeed. And the conditions are each trial is independent. If I do something one time, I don't get better at it the next time. So there's no improvement there. So when I'm guessing answers on a test, you know, what's the probability that it takes me the 3rd question until I get one right? You know, that kind of question. But the probability is the same each time I answer a question. So each trial is independent. That's just telling you don't improve each time you try something.
Previous trial?
Yep. So that makes the probability of success the same for each trial. So then this time our variables x, what was x on the binomial situation? What did x count? The number of successes. N was the number of trials. X counted the number of successes, how many times I was successful. This time x is going to be the trial number where I first succeeded. So x represents the trial number of my first success. So what's the smallest value x can take on if it's the trial number of my first success? 1. I actually have to try something. Where the binomial counted the number of successes, I could have no successes, so that was always 0. Here, it's going to start at 1 and work its way up to whatever x value. Okay, the by-hand formula. Well, and then P is still going to be the probability of success of a success. Q, probability of a failure. So the by-hand formula. So the probability of the first success happening on trial number X is you take your p-value and multiply it by q raised to the x minus 1. That's it. So that will be our by hand formula for what's the probability that my first success happens on the third trial. Is this built in? Yes. So this is going to be considered our by hand formula. This formula is built into Geomet PDF. Notice the P. Now look at the by hand formula. How many things am I going to have to feed this formula?
3.
Not really. 2, because Q can be calculated, because what do P and Q add up to?
1.
So if I give it P inside the program, it subtracts from 1 and figures out the Q, and you got to feed it X. So you only have to put P first, the probability of a success, and then X, the trial number of the success. And then if we want to add probabilities up, we're going to use the Geomet CDF, where you put in the probability of success and an X value, and then what this will do is it will do a whole bunch of PDFs and add them together for you. Where is it going to start at? What's the smallest trial number of the success? Trial number.
1.
I have to actually try 1. So it's going to add P of 1, the first trial, P of 2, and it'll stop at and include whatever X number I put on there. Just like the binomial one did. All right, so I've got one example with several parts on this one. And you're going to see it's very much like yesterday's, that same phrasing. Put that there. Here we go. So we've got a telemarketer. Horrible job. Has a probability of making a sale on a call of 0.23. So a 23% chance of making a sale each time they make a phone call and talk to someone. I don't know if I don't think I phrased that quite right, but. So, my question, first question, find the probability that the first sale happens on the third call of the day. So just by that phrasing, would you be able to pick this out as a geometric one? Because it's where that first success happens, not how many. I don't even know my total number of phone calls.
You say third day?
Third call of the day. Okay, so this is definitely a geometric, and I'm looking for the first success to happen on the third call. So what's my p-value for this problem? Probability of success? 0.23. What's my X value that I'm trying to find the probability of? 3, the third trial. So if I do this one by hand, we'll do the by hand in the program all at once, because you're going to have to show me you know which formula to use. So P of 3, according to the by hand formula, is the p-value times the q raised to the x minus 1. So what's my p-value? 0.23. What's the q value? 0.77 raised to the x minus 1.
2.
Okay, so you can type that in, or you can use the GeoMet PDF.
Okay, so it's not 0.23 times 0.77 and then all that squared?
No, just the Q is to that power. If it was what you wanted, you'd need parentheses around the P and Q with that thing on the outside.
Okay.
Okay. So this formula is built in where we put 0.23 and 3. Either one, they're both going to get you the same answer. What'd you come up with?
0.136.
136. Anybody verify?
Yeah.
136. No?
That's something different when I...
Do the PDF one?
Hold on.
Okay, I'll turn mine on. Double check. GeoMet PDF 0.23, comma 3. I got the same thing.
Mm-hmm.
Are you using the PDF or the CDF? Are you using the GeoMet?
Yeah, GeoMet PDF.
0.23, comma 3.
Oh, I was doing comma 2.
Well, there we go. Because you did the x minus 1.
Oh, I got it.
Okay. See, good thing you tried. Now you won't make that mistake. Ready for the next one?
I don't understand why it's less.
Why it's
Is it because first sale is on the third day?
right on the third call of the day.
Yeah, yeah. That's what I meant. So,
Yep.
like, if it was like
This is just the
just a
problem.
regular sale
Yep.
on the third day, would it still be 23%?
I don't know what you're asking me.
Well, like if it was just like
'Cause
not
what-
the first sale. but
Well, let's just because I think
first
we're the.
call,
Oh, yep.
would it still be 23%?
Yes, she still has a 23% on that phone call.
Okay.
It's still each time she calls, she's got a 23% chance.
Third call.
I mean, you start making enough phone calls, eventually you're going to make some sales, and that's what it's all based off of.
Where did you find
G, it's just below the
No, it's...
the binomes,
If you go to distributive, it's all the way at the bottom.
all the way at the bottom. They're all. We're going to use those bottom 6 because you're going to see the Poissons are down there too.
Oh.
I don't like that word.
You don't like Poisson? I don't. Poison? Well,
Why do we say it?
I don't know. I don't know how else to say it. That's the proper way.
Sounds fun.
Okay, now we'll say what's the probability that the first sale is made before the 4th call of the day. So where are we looking for this first sale to happen? On which calls?
1, 2, or 3.
1, 2, or 3. So we're looking for the probability that it happens on the first call, or the second call, or the third call. So we could use the PDF, find all 3 of those, and add them together manually. But we've got that nice little CDF which adds for us. Take it easy there, man. So, if we use the GeoMet CDF, we can save ourselves some time. We still have to feed it the probability of a single success first, which was still 0.23. What's the trial number that we want to have the program stop adding at? 3. So this will add P of 1 plus P of 2 plus P of 3.
Oh, so the difference isn't in the numbers, it's in which program.
It's in which program. CDF accumulates, it adds probabilities together. So it does a whole bunch of PDFs and adds them.
Okay.
And it's just built in. Oh, what chance? 0.54?
Yeah.
This should be pretty good. Pretty good chance. All right. What's the probability that she makes her first sale
Math.
after the second call of the day. No, I'm going to go fifth call of the day.
Hopefully she can make one.
After the fifth call. I don't know. Seems like call, I do it every time. Sale, A and L, must be an A and L I like to do that with.
You do that when
Oh.
you have a Y and
I don't
join
know.
another letter.
All right, so what does after the fifth call mean to you? Where am I looking for my first success to happen?
5.
After the fifth. So 6th, 7th, 8th, 9th, 10th, 11th, on and on and on and on and on. So after the fifth would be 6th. Just keeps going. Okay, so I wanted to add probabilities together. I don't know where it stops, but what happens is the farther out you get, the probabilities get so small that they just end up rounding to zeros. But anyway, can I get my CDF to start adding at 6?
Can't think about it.
No, I cannot. I can only, it's built in where it only starts adding at 1. But what do all of the probabilities add up to? 1. So when I'm not starting on the lowest end, we're going to do a 1 minus.
That's what I was talking about.
Okay, what's the bottom chunk that I want to subtract off? 1 through 5 I want to subtract off. So anytime it doesn't start on your lowest number, you got to do a 1 minus geomet CDF 0.23. What's the last x value that I wanted to add that's being subtracted off? Because this is the subtracted off part. 5. This should be a pretty small probability.
0.271.
Oh, not that small. 0.271 according to Matt.
We'll see about that.
And then I've got,
7.
and our last one here, first sale happens on the 3rd or 4th call.
You didn't use cursive, or?
Nope. Okay. This one's different than all of them. Here, see how it went after the 5th call, it kept going on and on and out to infinity. This one's stopping at just these 2. So CDF isn't going to help me because I can't do a 1 minus because I'm not continuing this on all the way up like I am here. So the only way to do this one is to actually do 2 separate PDFs and add them together. You have no other recourse on this one because you don't have all possible x values here. So x equals 3 or 4, so geomet PDF
I already did the 3.
0.23. Well, I'm just going to type it all into one line with a 3 plus, and you can type it all into one line, PDF, or you can use the 0.136 plus this second one.
I feel like telemarketers don't make
I don't think so either.
their sales. I feel like that many people just pick up.
I'm thinking they consider a call someone actually talks back to them.
Yeah.
You know, there's probably a little definition of what does it constitute. If someone hangs up on me, is that a call? Probably not.
Please leave me alone.
Yeah. So yeah, because there's no way. Because more people hang up on them than,
Don't answer.
yeah, don't answer. So I'm thinking if they actually physically talk to someone, then maybe this probability would make more sense. Get some old people. Maybe they have all old people in their list. And what did you get for an answer? Anybody?
0.241.
241.
Might be it for that example.
That is it for that example. We're moving on to the next distribution.
Oh, I thought that was just an old.
Oh,
Long
no.
as that one.
Exactly the same as this one.
We don't have enough.
241.
0.2.
0.241. All right, the second probability distribution is the Poisson.
That's actually a fish in
Reminds me
French.
of
Yep.
croissant.
Yeah, it makes me hungry.
Not everything makes me.
So,
Oh, that
Poisson.
chair makes me hungry.
Oh,
Probability.
It's not like poison, that's for sure.
Is that an N or an H?
N.
How do you spell fish?
Poisson probability
Sorry.
distribution.
Oh.
And this one's going to be the easiest of the three to pick out because they're going to give you a mean of something. So I'm going to kind of tell you what it is and then go into. So a Poisson probability distribution finds the probability that a specific number of occurrences take place within a given unit of time or space.
I'm not liking this.
Okay. So as an example, Gladstone School District could look at my past 20 years here and find the average number of sick days I take in a year. And then say they're making a budget for next year, or every teacher they could do this with, and say, well, what's the probability that my employees take 6 sick days in the next year? Or what's the probability they're going to take over 10 sick days in the next year, based on my average? Those are the kinds of questions they could answer and base their budget off of that. So, the conditions here, this time, X is going to represent the number of times the event occurs. X is the number of occurrences. Did I write occurrences? The probability of the event is the same for each interval. And we're going to call it good. So our by hand formula, the probability of X occurrences in an interval with a given mean is. So they're going to have, like I said, this is the only one of the three where it has to give you an average. How many occurrences, and on average, this is how many occurrences happen in this interval. So you're going to see the word mean somewhere in the given information. That's going to tell you it's a Poisson. Okay, the formula. You're going to take that given mean, raise it to the x, multiply by the constant e, and I'll show you where that is on your calculator, raised to the negative mu, all divided by x factorial.
Yeah, I'm not liking this.
Yeah, this one's kind of ugly, isn't it? Okay, where is it at on the calculator? Built right in.
Please tell me.
Poisson, PDF, PDF. If you take a look, there are 3 variables there. There's the mean, only 2, sorry, the mean and the x. The e is a constant, like pi is a constant, e is also a constant. You had it back in advanced algebra, and it showed up, I think, in your like interest, the compounding interest stuff.
Always
And the,
get
yeah, that's where it was at. I think that's the only time you saw it last year. So, you have to feed it the two things, the given mean and your x value. And then the Poisson CDF. Okay, remember x is the number of occurrences that happen in the interval. What's the fewest number of times something can happen? It could be 0. It might not ever happen. So here x takes on values from 0 and then adds consecutively. So I have one example here. Good? All right. So, example 2. A study was done at an intersection. The mean number of accidents per month at this intersection is 3. So they're giving me an average per, and it could be per unit of time or space. Here we're talking time for a month. That's what the average is. Now I can ask you some probability questions. So because they're giving me a mean per something, I know this is the Poisson distribution and not the binomial and not the geometric. That's how you're going to tell the difference between the three. If they give you an average per something, Poisson. So, can you find the probability that there are 4 accidents in the next month? So my question has to be in the same unit of time. I can't say per week, because I could actually, because I could divide that by 4 if we think about 4 weeks per month, but we're not going to. We're not going to get there. So this is exactly 4 accidents happening. What's that probability going to be? Let's do this by hand. So we're looking for this x is a 4. I want that one probability only. So P of 4 by hand is going to be, formula says take what's normally the average, what's the mean? 3, raised to the x power, which is a 4, times e raised to the negative 4, all divided by 4 factorial.
-3.
Definitely
Oh, -3. Sorry, you are correct. -3. The mu, negative mu, not negative x. Okay. So if I just do it by hand without cheating, 3 to the 4th. Your e is right here below the pi key. See here above the divide? So those online, that e is right here below the pi. So e raised to the -3. I'm going to get that answer because I didn't put parentheses. Divide by 4 factorial. We'll see. Did anybody get my answer without hitting enter halfway between?
That's right, I cheated.
You cheated. Well, I know I'm right.
Yeah, I cheated too.
You cheated too. Nobody tried it the challenging way?
Where do you
Okay.
want to get the factorial?
The factorial is under math and over to probability. Math, this key over here on the left, over to probability. And It's right below our NCR button we were using the other day. Yeah, so really on the test, all you've got to be able to do is plug the numbers into the right formula, and then you can see it with your PDF program. I'll never know.
Good question. Where does it seem low?
Right here.
Why does it seem really low?
Really low? 17% chance? Well, because 3 in a month is not a lot. Now you're increasing it by a whole, I don't know. But that is what it is. How about no more than 1 accident next month?
How many are there?
I've got D.
Where does that?
Oh, you are going to. No more than 1. No more than 1 accident next month. No more than 1 accident next month.
Actually, really well played.
0 and 1 I need. So, you could do 2 PDFs and add them together. Or because this is starting from 0, you can just jump right into your CDF. PCDF. Where you feed it the mu first. The mu is 3. What's the x value that we want it to stop adding at? 1. The average that's given. The mean that's given.
Why is it called
Mu? I don't know that answer either.
Isn't it just the mean?
The mean, yep.
Yeah, but why?
It's
The symbol is called
mu. That's a Greek letter.
What's for me?
Alright,
Like alpha, beta.
Yep.
I got a question.
What do you got?
What is that weird little hut symbol on there?
Oh, that's lambda. Oh, they're using lambda instead of mu. That's your mu.
I don't like that word.
What is lambda?
That's where the mean goes?
Lambda chi.
If you want to show it
Yep.
on there.
Yeah. So the program has, instead of mu, it has lambda. It's like an upside down Y. But that is the mu. Maybe our book is too old. Maybe they've switched. Oh.
It's like a crappy made hut.
Distributions. It's a lambda. It looks like that.
Actually, it's 0.1991, but I rounded.
What'd you get? Point what?
0.22. But I rounded.
Oh, it's 199?
Yeah, 1991.
1991.
But I rounded.
199. I like that better. 3 places. They usually go 3 on most of those answers. Let's do a more than 4. Let's go more than 3 accidents next month. I know. More than 3. More than 3 accidents at that same intersection next month. What does more than 3 mean to you? 4 and up. 4, 5, ... Doesn't stop. What's our trick to doing these ones that don't start on the low end? 1 minus. What's the chunk we want to subtract off? 0 through 3, actually. So it's a 1 minus. Poisson. I wanted to add 0, 1, 2, and 3. I wanted to add these together. CDF. 3 is the average. And what's my last x value? 3 again. So 3, 5, 3, we went 3 places. I think we're good there. I have a worksheet for you.
No, you have to.
Yeah, we don't need D, it's just an at least. You're good. I think you've got an understanding for the phrasing anyway.